Hi everyone, for today's lesson, we are going to be practicing how to simplify radical expressions. So this is called Simplifying Radicals Algebra Review, and we're going to be practicing what we have already learned about in our interactive notebook. So as you do recall, we learned how to simplify radical expressions. I gave you a list that I would prefer you to know and study and have memorized. This is a list of all of our perfect square factors going from 1 to 20, as well as a couple special ones that you may see as we are working. You will need to have this list and use it as we are going through and simplifying values. All right, let's go ahead and start at the very beginning with simplify the square root of 24. So what we want to do is we want to look for a perfect square factor that can go into 24. And so what might be helpful is at the very top, writing down all of our perfect square values, starting at 1. So I'm going to write down 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. That's 1 through 10. Then we have 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. These are all of our perfect square numbers going from 1 all the way to 400, so that's from 1 to 20. Then we have a couple extras, which are 625. That is equal to 25 squared. And we have 900, and that comes from 30 squared. So those are some special ones that you may see as well. Okay, so looking at the number 24, which number can go into 24? 4. So this is going to be equal to the square root of 4 times 6. I know that the square root of 4 is 2. So the answer is 2 square roots of 6. So I just took the square root of 4 and out came a number. 6. None of these numbers can go into 6. So therefore, this is simply what our answer is. Let's look at the number 20. What perfect square number can go into the number 20? 4. This is equal to the square root of 4 times 5. If you want, so this was the shortcut, a longer way is to split apart the square root into the square root of 4 times the square root of 5. The square root of 4 is 2, so this is 2 times the square root of 5. That is simply our answer. This extra step is really helpful if you need to see it, but a lot of us don't need to see it, so you would just skip that step. I just wanted to show this as an option. Number 3, what perfect square number can go into 45? Well, 4 doesn't work this time, but what about 9? Yes, 9 can go into 45. Is that the biggest? Yep, that's what it looks like. So this is going to be equal to the square root of 9 times 5. The square root of 9 is 3, so this is 3 square roots of 5. All of the highlighted ones, I would like you to go ahead and pause the video and try these two on your own. When you have an answer, please go ahead and restart the video and we will see how well you did. All right, let's go ahead and see how well you did. So for this problem, 75, we want to look for the largest number that can go into 75, and I see that 25 can go into 75. This is 25 times 3. The square root of 25 is 5, so this is 5 times the square root of 3. 72 is kind of tricky. A lot of us probably saw that 9 works, but in reality, the largest perfect square number is 36. So I'm going to show both ways. If you saw that 36 works, this is the square root of 36 times 2, which is 6 square roots of 2. but a lot of us don't see that. So you probably saw that this was equal to the square root of 9 times 8. The square root of 9 is 3, and we end up with the square root of 3 times the square root of 8. But remember that you need to have, like you're done when underneath the radical, there are no other perfect square factors. And I know that 4 can go into 8, so I need to keep going. So because I need to keep going, I know that this is 3 times the square root of 4 times 2. The square root of 4 is 2, so this is 3 times 2 times the square root of 2. And I still end up with 6 square roots of 2. So both ways will get you the same answer. It's just one way is a lot faster, and that's looking for the biggest perfect square factor. All right, let's go ahead and look at number 6. For example numbers, this next section, we're going to be multiplying and simplifying radicals. So remember, looking back at our interactive notebook, in order for you to multiply radicals, you multiply the numbers in front together first, then multiply the radicands, that's the number under the square root, second, and then you simplify the radical completely if necessary. So in this problem, there are no coefficients that we can see, so we just multiply our radicals. This becomes the square root of 9, and we know that the square root of 9 is 3, so the radical goes away, which is pretty cool. Same thing happens with number 7. 10 times 10 is 100, and the square root of 100 is 10. Number 8, though, is a little bit different. This one I'm going to multiply 6 times 3, and I end up with the square root of 18. Now, 18, it has perfect square factors. The perfect square factor that can go into 18 is 9. 9 can go into 18. So this is 9 times 2 underneath the radical. Notice that I keep the radical each time until it's gone. So I have the square root of 9 is 3. 3 times the square root of 2. I'm going to keep going. Notice I have some highlighted ones, so I'll ask you to pause the video in just a moment to try these on your own. But I'm going to go ahead and show you number 13 and number 14. So for number 13, notice that I have a parenthesis squared. Whenever this is called raising radicals to a power. So whenever you're raising radicals to a power, powers just mean exponents, and typically for our class you'll see a square. There are 2 different ways you can do this. You can distribute the square to each term, or to each piece, to make this 2 squared times the square root of 7 squared. We know that the square and the square root can eliminate, leaving us with just the number 7. So 2 squared is 4, times 7 will give us 28. That is one way to solve this. Another way to solve this is to rewrite 2 times the square root of 7 as 2 separate pieces. So you would multiply the coefficients together. 2 times 2 would give you 4. 7 times 7 will give you 49. The square root of 49 is 7, so we have 4 times 7, which is still 28. Both ways will get you the right answer. It just depends on what you want to do. Personally, I think that distributing the square is faster, so this is the way I'm going to show you. So for 13, I'm going to distribute the square to each piece. So I have 4 squared times the square root of 2 squared. 4 squared is 16 times the square and the square root eliminate, leaving me with the number 2. 16 times 2 is equal to 32. For these types of problems, the square root will always eliminate. Let's look at 14. 14, look, I only have coefficients on the outside that need to be multiplied together. So I'm going to multiply 2 times 12 to get me 24, and it's times the square root of 24. Now, 24, we already know has a perfect square factor of 4. So I'm going to rewrite this as 24 times the square root of 4 times 6. The square root of 4 is 2. So this is still 24 on the outside, but this is going to be times 2 times the square root of 6. 24 times 2 is 48 square roots of 6. All right, please go ahead and pause the video and try numbers 9, 10, 11, 12, and 15 on your own. Please restart the video once you have an answer, and we'll see how well you did. Okay, let's go ahead and look at number 9. For number 9, I'm going to multiply the numbers underneath the radical together. So I have 4 times the square root of 5 times 5, which is 25. So this is 4 times the square root of 25. I know is 5. So this just becomes the number 20. Let's look at number 10. I'm going to multiply 10 times 2 to get 20. So this is 7 times the square root of 20. I know that 20 has a perfect square factor of 4. So this is 7 times the square root of 4 times 5. So this is 7 times the square root of 4 is 2 times the square root of 5. 7 times 2 is 14. So 14 times the square root of 5 is my answer. Let's go ahead and look at number 11. For number 11, I'm going to multiply 2 times 5 to get 10. So I end up with 9 times the square root of 10. No perfect square numbers can go into the number 10. It's not divisible by 4 or 9 or 16 or any other number. So we just simply leave our answer just like this, 9 square roots of 10. And there's no other simplifying that we can do. For number 12, 2 times 14 is 28, so 4 times the square root of 28. I know that 4 is a perfect square, or is a number that can go into 28. So I'm going to rewrite this as 4 times the square root of 4 times 7. So then I'm going to write 4 times the square root of 4 is 2 times the square root of 7. 4 times 2 is 8 times the square root of 7. And now 15. So I'm going to show it in a different way than what I did in the example. I'm going to show this as 3 times the square root of 5 times 3 times the square root of 5. I'm going to multiply 3 times 3 to get 9 and 5 times 5 to get the square root of 25. So I know that the square root of 25 is 5, so this is 9 times 5, which is 45. The square root completely eliminated. All right, finally, let's go ahead and practice simplifying each expression by rationalizing the denominator. Now remember that rationalizing the denominator means that we need to eliminate the root or the radical that's in the denominator. You can't have a root in your bottom. So the way to get rid of it is you want to look for a relationship between the radical in the numerator and the radical in the denominator. Does a relationship exist? If it does exist, simplify just like we did in this step. If there is still a radical in the denominator after completing step 1, then you'll multiply both the numerator and the denominator by that root that's down there. When you do that, you'll eventually end up with a radical that you can simplify, and that eliminates the radical in the denominator. And that process is called rationalizing the denominator. Now be careful. Just because the root in the numerator and what the number in the denominator might be the same, you can't cancel because these two numbers are different numbers. Let's go ahead and look at example number 16. Well, I don't have a root in the numerator, so that tells me from the very beginning I'll need to multiply both the numerator and the denominator by the square root of 3. So I'll multiply straight across and I end up with 2 square roots of 3 divided by the square root of 9. The square root of 9 I know is 3, so the answer is 2 square roots of 3 over 3. let's look at 17. I'm going to multiply both the numerator and the denominator by the square root of 2 since there's no simplifying that I can do. If 4 was under a radical, I could probably simplify that. But because it's not, these two numbers are completely different than like a 4 and a normal 2. So I'm going to multiply straight across and I end up with 4 square roots of 2 divided by the square root of 4. The square root of 4 I know is 2, so this is 4 square roots of 2 over 2. And what's really cool is that these two numbers are both outside of the roots and they are related to each other. And I can simplify this even more. 4 divided by 2 is 2 square roots of 2. Let's go ahead and look at number 18. For 18, square root of 3 and square root of 2 have no relationship. So I'm going to multiply the square root of 2 by both the numerator and the denominator. Multiplying straight across, I end up with the square root of 6 divided by the square root of 4. I know that the square root of 4 is 2, so I'm going to rewrite this as the square root of 6 over 2. Now you cannot simplify these because the square root of 6 is not a normal 6, so we leave our answer just like this. For number 19, 5 and 3 are not related to each other, so I'm going to multiply both the numerator and the denominator by the square root of 3. So 12 still stays on the outside, and I'm just going to multiply my roots together. 5 times 3 is 15, divided by the square root of 3 times 3, which is 9. So 15, 4 can't go into it, 9 can't go into it, 16 can't go into it, 25 can't go into it, so 15 stays the way that it is. So it's 12 times the square root of 15 divided by the square root of 9 is 3. Oh, look at that, a relationship. 12 and 3 are not inside of the radicals, and they are related to each other. 12 divided by 3 is 4. So my answer is 4 times the square root of 15. I have the next 4 problems highlighted. I would like you to please go ahead and pause the video, try these problems on your own, and we'll see how well you do. All right, let's go ahead and see how well you did. Let's look at number 20. In number 20, we have the square root of 21 over the square root of 3. Look at that. 21 and 3, they are related to each other. I know that I can simplify 21 over 3, and that's going to become the square root of 7. So that's all you needed to do for that problem. If you had multiplied both the numerator and the denominator by the square root of 3, that's okay. You can do it that way, but it's a lot of work. You'd end up with the square root of 63 divided by the square root of 9. Square root of 63 can be simplified even further. That's the square root of 9 times 7 divided by the square root of 9 is 3. The square root of 9 is 3, so 3 square roots of 7 divided by 3. The 3's cancel away, leaving you with the square root of 7. Both approaches get you the right answer, but clearly seeing the relationship is a lot faster. Let's look at number 21. Look at that, 6 and 2, both under the root. They are related to each other. I can rewrite this as 8 times the square root of 6 over 2. 6 divided by 2 is 3, so that's 8 square roots of 3. Number 22, look at that. 10 and 2 are both under the radical, and they are related to each other. So I can rewrite this as 8 times the square root of 10 divided by 2, and that is 8 times the square root of 5. And finally, 7 and 2 are not related to each other. So that means I need to multiply both the numerator and the denominator by the square root of 2. So this becomes 12 times the square root of 7 times 2, which is 14, divided by 2 times 2, which is 4, square root of 4. I know 14 I can't simplify because 4 can't go into it, 9 can't go into it, 25 can't go into it, so I'm just going to leave it just like that. 12 times the square root of 14, and the square root of 4 is 2. Look at here, 12 and 2 are outside of the radicals, and they are related to each other. 12 divided by 2 is 6, so our answer is 6 times the square root of 14. And that is the end of today's lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.